Okay, this one may be a fun one. So things rotate when approaching the speed of light because the natural state of objects is this rotation. We just don't observe it because we all move at the same rate. When something moves faster, it starts to spin faster as well, and we can begin to observe this effect. This actually ties in well with my theory of temporal stability and that everything is rotating in time. We just don't perceive it in our reality. However, it can be glimpsed if we look hard enough. So, um, basically, there's a prediction, and there was a study that was done somewhat recently that sort of simulated this by taking a lot of photos and then moving it um really like sliding through them really fast, or I'm not sure exactly what they did, but they did some kind of experiment to try and test this theory, and they found it to be seemingly correct from my understanding. um And there's a prediction out there that as you approach the speed of light or the speed of causality, things will appear to rotate as you move past them. And there's some kind of simulator game where you could go around and collect like a bunch of like balls or something, and as you collect them, you move faster, and so you perceive what it would be like to move at a certain percentage, the speed of causality. And when you start to get up there and you're moving really fast, you observe this spin start to occur in this game. But obviously, no one has physically observed this because you would have to be moving at the speed of light to, or near the speed of light to do it, right? And so it's potentially never actually possible for us to do this. But if you could do that, then you should observe this thing happening, right? And I think the reason why this may be has to do with my theory of temporal stability and the fact that everything is potentially rotating in time. In like a temporal dimension, there's a temporal relativity, and so we don't observe this oscillation in time because we are oscillating with everything else. And exactly what that means and what that looks like, I don't know. All right, I don't know. I'm just a guy. um, but I think that it's potentially possible and could be and would make sense with my theory, and scaling down and looking at my equation and how I think it should play out. There should eventually become a point where there is time relativity, because there is the current obvious relative velocity. Then there is the potentially on the cusp of us discovering, which we've technically already observed but not realized its significance yet, is relative mass in neutrinos. And then if you kept going really, really, really small, like past dark energy probably, you would find potentially relative time. This is very interesting and, potentially useful, maybe not useful at all. I don't know if you would ever need to actually pull that into your equation or not. I would imagine that if we wanted to get just insanely precise, then it would need to be accounted for at some point. But I don't know if we will ever get to a point where that's really necessary. And if we do, then props to us. Way to go. At that point we would have probably broken way past our limit of the Planck length and things along those lines, which would be very impressive because apparently that's impossible. But yeah, so I don't know, but I just think it's very interesting that this rotation thing is a thing, and I had heard about it before, but I wasn't really thinking about it. But I recently saw a video where it was mentioned again, and I was like, you know what? I think that kind of makes sense, right? Because if everything is rotating at the same rate, it's got to be rotating really fast, and we just don't observe it. But if you were moving really fast, then that would start to create a difference that would slowly become more and more observable, and you would start to see this sort of rotationing, like this asynchronicity between the world around you, because you're observing things rotating that are technically not, but actually maybe it is that they actually technically are, we just don't observe it that way. Because I guess the way you could look at it is like, imagine, a great example of this is a wheel. This is actually a really good example. So if you look at like the wheel on a car, as it speeds up, right, it's, it reaches a certain point where it looks like it's not even spinning, right? And then if it goes a little bit faster, then it starts to look like it's going backwards rather than forwards, right? That is what I think this time relativity looks like. Everything is spinning at a rate where it appears that it's not even spinning at all in time, which is weird. And I'm not going to say it's not weird, and it doesn't seem to make sense in our perception of reality, but I think that it makes sense in the grand scope of the universe. Not even just the universe, but just, I don't know. I think there needs to be the super universe. I don't know. I think there needs to be a term bigger than universe, because I think our universe at the end of the day is still within something else, and that goes on to infinity. But I think that saying the super universe is more accurate than the universe itself, right? Because we need to think that like everything in the universe is going to be within this relative time potentially, and everything's going to be oscillating through time at the same rate, because in theory the energy within the super universe is relatively constant, and so because it's relatively constant, time flows at this set speed. This is constant to us, but on the grand scheme of things, it is fluctuating and it will change. Will it change in a way that's perceivable to us on our lifetime, or the lifetime of the entire human race, the lifetime of stars? It's potential that the fluctuation is, because we're looking at scales so large, the time it will take for just the slightest fluctuation could be potentially infinite to our perspective. It would seem like it would never happen because it would just take so long for it to take place. But the reality is that there should be some kind of transition actually happening. It's just really, I don't know if I don't know if there's even a point to think about things that far out, because it's just like, I don't know if it'll impact us in any meaningful way. But I do think that it's still there, and so it's fun to talk about it. But yeah, pretty much everything is oscillating at this thing, and that's why we go into the whole causality thing. If you start to spin faster than this set speed, then things will start to you'll start to observe things rotating again, because you're not spinning at that equilibrium speed. Now that you're not in sync, it appears like everything else is spinning and you're not. And then, you also, as you approach this, speed, then you start to approach the speed of causality. When you start to approach the speed of causality, you no longer are bound by this quote unquote time, and you could technically start, you would appear to be going backwards in time, even though you're still moving forwards, which is just a whole nother weird thing as well. And like, it totally breaks our concept of time and what that even is and all these things. But I think when you look at a wheel spinning, that is probably the best explanation as to why it is that way, and or not necessarily the best explanation, but the best relation to why it is that way and what it looks like, in a way that we can actually observe and comprehend, right? And so, I don't know. I don't think I have anything else to say. I think that it's very interesting. I think that there's just the way everything works, if I'm right, like if I'm right, the way everything just kind of works is just so crazy, right? And it's crazy in a way that is logical and makes sense. It's just crazy that that's what that leads to, right? And this is like, it's absolutely absurd, and I understand that, but at the same time, like, quantum mechanics and like quantum physics is no better, and at least I've got some logical reasoning for where this stuff is coming from, rather than an assumption and a whole lot of, I don't know, it's weird. So, yeah, I don't know. Yeah, I think mine's more fun. So I think infinity is way more fun than a bunch of waves just like jiggling about for some reason, somehow. um, yeah. Yeah. Peace out.